Good morning, folks. How you doing today? Happy Thursday. No, Wednesday. My goodness, Wednesday. I know what day it is. I knew it was Wednesday, too. Just the wrong day came out. Alright, hope you got your coffee. Got a full mug here, and this way so I don't have to take so much time. I brought the pot, too, so I can refill. Hey, good morning, Carter. Hey, good morning, David. Benny? Alright. So, got a couple things today. Don't forget it is the 19th, so the syllabus quiz is due, and also the Chapter 1 quiz is due. So those ones are due tonight, 11:59 p.m. I think just about everyone else got the Lab 0 in. If you're still having trouble with Lab 0, let me know. I know I got like one email this morning at a really weird time. So that's fine. I want to make sure everyone gets their tools up and running for this first lab. So if you need a little bit more time on it, I'm okay with that. But schedule a meeting with me. We'll do some screen sharing, figure out what's not working for you here. Top of the morning to you, Red. Awesome. All right. So we've got most of that in. I was trying to get those ones graded right away. So let's take a look at our schedule here. It's a little bit funny because we missed Monday, so our weeks are a little bit split. No, that's not what I wanted. I wanted the syllabus. Weeks are a little bit split here. So we've got today and then Monday to finish a topic. And we follow that pattern for quite a while. So it's going to be a little bit weird. And we're actually behind the Tuesday night class, but that's okay. So we're going to start on Chapter 2 today, and then we'll wrap it up on the 24th. Okay? That makes sense? And then next week, the 26th, we start with Chapter 3, we wrap it up on the 31st, and on and on and on. So we'll talk about the first project today. The lab I had planned, I don't know if we'll actually, I don't think we're going to get far enough into the chapter to talk about the lab. Because, again, my plan is only talk for about half the time or so, and give you the other half to work on the lab. So, we'll see what we get. Yeah, I think we'll have to do a different lab, but that's okay. So we'll talk about the lab assignment for today, and then we'll talk about Project 1, and that'll be due on the 2nd. So it should be 2 weeks for that, to get that one up and running, and we should be in pretty good shape. We'll just kind of follow that pattern as we go. So next week, we probably won't have quite as much to cover on the Monday, but that's okay. I think that'll work out. All right. So, I'm going to fire up NetBeans here. Look at that, I've already got it here. And I'm going to start up a new project. This is Java with Ant, a Java application. Let's call this Chapter 2. And I'm going to make sure I put it in the correct repository. This is the important part. If you want Git to be able to see your stuff and be able to push the stuff to github.com, you need to make sure you put it in the correct repository folder. They're just folders, right? So as you go, you'll have the Lab 1, you'll have Lab 2, Lab 3, Lab 4, on and on and on. You'll have project folders. Just make sure you put it in the right one here, okay? So this goes in my Monday, Wednesday folder for all the examples. And I'll say finish, and it's going to start all the stuff. And then I can go check the GitHub client, right? Make sure that it sees all of the changes. So if I see new files, I know I put it in the right location. So I'm going to open it up and give it a quick check. While that loads, I forgot to restart the computer. I wonder if that's why it's like extra slow right now, but I think, let me just close this down. See if that frees up a little bit more. All right. Okay, that's not so bad. And then in the GitHub client, again, you got to go pick the repository so you can flip between them. So I'm going to go find my CIS 1500, winter 2022. And mine is Monday, Wednesday for today. Let's see. Maybe that'll load. Thought I was typing. Alright, we made it sad. Need to free up more resources, apparently. Not that one. Ah, okay. There we go. Here's the Monday, Wednesday repository. Just needed a second to think. And it says, hey, there's a bunch of new stuff from Chapter 2. Check that out, which is good. All the other files, the build, manifest, NB project files, leave those all alone. Those are all NetBeans projects files. We like all of those. The important one here is the Java file. Right? But everything else is fine. Just leave it be. If they change, they change. If they show up, they show up. No big deal. We see our Java file. So we know we got it in the right location. Now, here, again, I'm going to get rid of some of these initial starting comments. We'll talk more about comments in just a little bit here, but they just kind of take up some fluff for me. And this is where we're going to start, right? Hector, thank you so much for the bits and donating to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. That's so cool. Thanks for following along with us. All right. So for now, everything we're going to do is inside of this set of curly braces here. So we're going to talk a little bit more about the Java syntax. Right? The idea with the Java syntax is Java needs to be able to read and understand our code so that it can tell the computer to do what it's supposed to do. Now, when we write code, though, it needs to follow the rules of the syntax, but we're not writing the code for the Java compiler. That's not the main goal when we write code. The main goal when we write code is so that people can read it. So you can read it, I can read it, that whoever you're working on a team with can read it, and that sort of thing. And I always like to imagine that, you know, when you get out into the industry and you start working on amazing projects and you do really cool things, you know, imagine you're going to move on to bigger and better things relatively quickly, I'm sure, because you folks are awesome. And someone else is going to have to pick up where you left off. So a lot of times what happens is we get a program up and running and it starts working and people love it in our organization, and then they want some changes. And to change a program, you have to go in and read the code. And if you're not there anymore because you've moved on to bigger and better things, someone else is going to have to read your code and change it, right, and maintain it and keep it up and running, that sort of thing. So programs generally have a pretty good lifetime if they're useful for that sort of thing. So someone else is going to have to read your code. So we're writing the code so that it makes sense to us and makes sense to other people. And, you know, specifically for the class, you're writing it so it makes sense for me so I can score it for you. Now, I'm not all that particular. There's lots of ways of writing code, lots of conventions and standards and things that people will do or organizations will follow. Generally, if your code does what it's supposed to do, and when we talk about the first project today, I'll show you, like, it will do this thing, it will do this thing, it will do this thing. I could care less how you get it done. I don't care if the code's ugly, right? You're going to get the points for getting it done, and I'm fine with that. But ideally, it's readable and, you know, understandable, and I can look at the code and follow it, rather than have to, you know, scratch my head and be confused. But and what that means is when we start doing things in Java, we want to keep that in mind, that we want it to be readable by people. So far, the only thing we've done are the system.out.println commands. Println in parentheses and then a set of quotes, right? And what we saw was this will make something show up on the screen when we run our program, right? You know, hi there, which is cool. I mean, it was nice to be able to show something on the screen, but it's not all that useful for a program right now. Let me close this other project. Make sure I don't get confused. So if I run it, you know, I should see hi there show up, and that's good. But now we're going to start looking at what are other things we can do with Java. And for programs to do additional things, oh my goodness. So it's been working great. If you run and you don't get any output, there's probably an issue with one of the plugins. Let me go to my plugins. And I've got one. This is the one that bothers me all the time. It was working great earlier. So the NB Java C plugin here is this one. I'm going to deactivate it, and then I'm going to reactivate it. Oh, I have to restart. Oh my goodness. I'm going to restart later. That's fine. And then I'll see. Can I can't. I have to restart NetBeans. That's really sad. I'm going to restart NetBeans because I really want that to work. It's annoying when it doesn't. NetBeans is a little bit particular. It's unfortunate. But that's okay. That means we get a coffee break. Good news? Throw your coffee emotes up in chat. Get some coffee. I do love this mug. It's huge if you couldn't tell. Like that's my fist around the mug. So it's a nice size mug here. And then I have my thermal carafe. These are the best things, by the way. So they don't keep the coffee hot. With a burner, it just, when the coffee is brewed, it sits in here and it's like a little thermos. It is amazing. So then you just push the little lever and hot coffee comes out, and it is awesome. Listen to that sound. Isn't that amazing? That's like one of the happiest sounds. Hydration. Thank you so much, Fallen. You know, I've been told by people who are smarter than I am that coffee is not hydrating and it's a diuretic. I'm sure it's true because they're pretty smart people, and I think we Googled it. But I'm going to drink the coffee anyway and call it hydration. Is that okay? There we go. All right. NetBeans is unhappy with me again. And now in Windows 11, you used to be able to like right-click down in the taskbar and you could get the task manager. That's not there anymore. But if you are a fan of keyboard shortcuts, Control, Shift, and Escape all at the same time will launch Task Manager for you. Control, Shift, Escape. It's a lovely keyboard shortcut. I don't know why, but that's the shortcut for Task Manager if you don't have that right-click anymore because you're on Windows 11. Let's see. Yep, it's thinking real hard. It's just eating a lot of CPU here. This desktop window manager, I keep forgetting I need to like do a fresh reboot before I start because this thing just sucks. I don't know why it comes up, eats a lot of CPU, but I think killing it was bad news too. I want to say. Yeah, I know. Okay, so now it's not. No, yeah, so it goes back and forth between eating all my GPU or not. But NetBeans is working hard. There it goes. Are we back? Okay. I'm going to go back to my plugins and try that one more time. I really want that thing to work. The other option we have is going to the project properties. So you right-click the project here. Actually, let's try the plugin first, and then we'll try our option 2. Go back to my plugins. It's working on it. Find my plugins. Find the user installed ones. NB Java C. Check the box and activate. Activate. It's going to make me restart again, isn't it? Yeah, it's going to make me restart. It's worth it. It's worth it. Because now I get to avoid like changing one setting. Oh, we didn't even have to restart. Look at that. Cool. All right. Now we'll go back to Chapter 2. Open up our chapter2.java file. Now when we hit run, we should get, hi there. And we'll be very excited. We should. I got my fingers crossed. I don't know who decided that was the sign for good luck. Yeah, alright, we get hi there, so the plugin's working. The other option you have, if you don't want to go through all of that, you right-click the project and go to Properties. You go to the compiling setting over here on the left when that loads. And you uncheck this compile and save that requires the Java, or the NB Java C plugin. That's NetBeans Java Compiler. NetBeans Java C. Sure. Why not? Alright, so we love an integrated development environment. That's what this is, this NetBeans tool. There are other ones that are popular. Eclipse is pretty popular, and then IntelliJ is supposed to be really good. I've heard good things about it. tempted to switch just because NetBeans gives me such a headache. And then also I've had people use VS Code, which I'm really tempted to look at as well because I love VS Code. But NetBeans has a really good debugger, and it does all the things we want it to do. And okay, maybe maybe we're putting up with too much, but it works. Even if you have to kind of massage it a little bit and coax it into doing the right thing. But behind the scenes, it does some really cool stuff. So remember when we went and downloaded the JDK? That's the Java Development Kit. That's all the tools we need to develop Java programs. Right? And I said, hey, let's go put it on C, and I put it in OpenDev, and you can leave it anywhere you want. It doesn't matter here, but I want to show you inside of that folder is a couple other folders. One of them is bin, which is short for binaries. So this is all the executables, this is all the programs and the DLLs, all the other code that you need for Java to run. And one of those executables is java.exe. That's our Java runtime environment right here. This runs Java. Right? This would come with the Java runtime environment that gets installed, not just the Java development kit. What you get with the Java Development Kit is you get some other cool executables like javac.exe. This is the Java compiler. You get javadoc and some other cool ones too. We won't worry too much about that. But javac is the big one. So javac's job is to take readable Java code and convert it into the Java Byte code, the .class files that get created, that then the Java virtual machine, or just-in-time compiler, will go and read and use to tell the operating system what to do. Remember, because Java can run on all sorts of different operating systems. It's not just Windows specific. And the way that it does that is this Java program here, the java.exe, is written differently for different operating systems. That's why there's a Windows install, a Mac install, a Linux install, mobiles, all sorts of other devices have different Java EXEs that know how to talk to their specific operating system, which is really cool. Right? So Java's pretty portable. So to do this stuff by hand is it's not actually the hardest thing in the world. It takes a little bit though. So I'm going to go to this repository menu and say open in PowerShell. Now, if this makes your eyes glaze over, it's okay. It's worth getting familiar with the command prompt or PowerShell or terminal, something here. Definitely going to be worth your time. But don't worry too much about it. We don't really have the time to get into it. But I want to show you how this works because it's really fun and really neat. And then you can appreciate that the IDE does a lot of cool stuff for us. So I'm going to go CD for change directory to my CIS 1500 winter 2022 folder, and tab will autocomplete here. So 2022, we want the Monday, Wednesday folder here. And I can say ls to list what's in here. And I see I've got my chapter 2 folder, the hello world. I've got another Java application out there. Sure. So let's cd change directory to chapter 2. And inside of this, I have my build, my NB project. I have the source directory. So source is where I want to go, right? So src, so cd for src into source. And I've got that chapter 2 folder. So cd into chapter 2 again. List, and now I have my chapter 2.java file. This is the important file here. So if I know where my Java file is, I can ask the javac program to go compile it. So I know mine's installed C:, OpenDev, JDK, bin, javac, and I'm going to tell it, please compile the chapter 2.java file. So again, I'm not typing all of this stuff. It looks like it's going really fast, but tab will autocomplete anything. Just like when we're typing in NetBeans and it brings up a name, we can tab to autocomplete it. Same thing here. So I just start typing the path, tab to autocomplete. So we're saying, hey, javac, please go compile this. It says, okay, sure, I'll go compile this for you. And now when I do my list here, I see there's a .class file. Remember, .class, this is the Java byte code. This is what the Java virtual machine or just-in-time compiler can understand. This is the thing that's portable. We can send between any operating system. So to run it, I actually need to be up one directory. So cd ... puts us back to source. So because we're inside of a package here, I have to run it from in that package. So I can't be inside the chapter 2 folder. I have to be outside that folder to call this. Don't worry too much about it, but it's just a little bit of that nonsense. I'm going to say, hey, I want to run that Java program. So I'm just going to hit up a couple times to get my last command. and go change this. So I don't need Java C, I want java.exe. And then all I do is I tell it, hey, I want to run chapter 2. I don't need to tell it .java or .class. I just say, hey, Java, run this thing called chapter 2, and it will go find it. Oh, no, sorry. I need to tell it it's inside the chapter 2 folder. Chapter 2, sorry, chapter 2/chapter 2. There we go. So I tell it, hey, run the thing inside this package, which is just a folder. Here's the name of the Java program to run. And then it says, hi there. Right? That's the output that we got. So you can run Java programs by hand. I don't recommend you do it. Right? But eventually when you want to go tell someone else to run your code, you probably don't want them to have to install NetBeans to run it. So this sort of thing is how we can make Java programs run, at least from the command line here. All sorts of fun stuff. Again, don't worry too much about it, but this is all the magic that's happening behind the scenes when we just hit run. It just goes and does the right thing for us, which is awesome. Right? That's the Java with Ant, or Java with Maven, or Java with Gradle. It does all that building behind the scenes for us. It's super cool. Okay, so we did hi there. Now, it's not all that useful to just print commands, right? What would be more useful for us is if our program could, actually do something rather than just print things to the screen. So the way that we tell Java we want to store information so we can act on it is with something we call variables. Now there's lots of different kinds of variables, lots of different ways of storing information. We're going to look at a couple of the common ones to start. So if you want to store something that's a numeric value, that is an int, which is short for integer. So ints are whole numbers, negative or positive numbers here. We'll say this is, I don't know, how about my favorite number? So we tell Java, hey, I want something that is an integer. I'm going to call it my favorite number. So this is my variable name for it. This is a programmer assigned name. You get to pick these. They can be anything you want. It could be the letter A. I don't recommend the letter A. That's a terrible variable name because I have no idea what that means. But if you see my favorite number, you probably have a pretty good clue of what this variable is. And that's this idea. We want the variable names to be descriptive of what we're doing with them. So I can tell Java, okay, hey, I want an integer. I'm going to call my favorite number. And then I use the equal sign. So this is not the equals sign or equals operator here. We call this the assignment operator. It says, hey, take a value that's over here on the right and assign it to the thing on the left. And I'll say my favorite number equals 42, and then we end with a semicolon. Pretty much every command in Java will end with a semicolon. Not every line, but every command, right? There's no semicolons here, none up here, but we'll talk more about that as we go. So my favorite number equals 42, semicolon. So now Java is storing this integer value of 42 in a variable called my favorite number. So if I wanted to, again, I'm going to use my shortcuts, right? So SOUT for system out, and then tab will autocomplete that. I can say Eric's favorite number is, and then if I want to take this value here, whatever's stored, I'm going to take my favorite number. I'm going to say, hey, can you just add that to this output? Now, it's not doing arithmetic. It's not really adding because here's a bunch of text. And I'm not adding the number 42 to a numeric value. I'm just saying, hey, take this bunch of text here and stick this value on there. So this is going to concatenate this value into a bunch of text here, which we call a string. So a string is a bunch of text. Strings have quotes. So take the string, jam a number on the end of it. So when I run this one now, it should tell me, hey, my favorite number is 42. And if I change this value here, right, anything that's stored here, anytime I tell it to store a number in the output, it's going to use whatever that current value is. So what happens behind the scenes, this is really cool. Again, probably another point where your eyes are going to glaze over, and that's okay. Don't worry too much about it. But it's cool to understand how this works behind the scenes here. Is everything in your computer is eventually stored in something called bits. So a bit is either 0 for off or 1 for on. That's off or on. That's a bit. Right? So that's how our computers store information. Everything is broken down into individual bits. What we generally do is we group 8 bits together into a byte. So let's say 1, 2, 3, 4, 5, 6, 7, 8 bits equals 1 byte. Okay, so 8 bits makes up 1 byte. And then we group these bytes together to store information. So what we get is an integer is 4 bytes. And now bytes are binary or base 2. So what that means, you remember our regular number system, right? You have, say, like the hundreds place, you have the tens place, you have the ones place, right? So this is hundreds, this is tens, and this is ones. Excuse me. I think you need a little more coffee here. The only downside is it's really heavy to hold, like just with one finger. But the 2-finger grip, I don't know, maybe I could do the 2-finger grip. It just feels funny. There we go. So how this works, because this our regular number system is actually base 10. And that means each one of these is 10 to a power. So this is 10 to the 0th power, this is 10 to the 1th, 10 squared, right? And thousands is 10 to the 3rd, 10 to the 4th, on and on and on. So 10 to the 0 is 1, 10 to the 10 is 10, 10 squared is 100. So anything in here represents that many of that value, because it's base 10. So with binary, binary is base 2. So with binary we get, let's do 1, 2, 3, 4, 5, 6, 7, 8. We get 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. So it's 2 to a given power. So 2 to the 0 is 1, 2, 4, 8, 16, 32, 64, 128. And on and on and on and on we go. So to store a number in binary format or base 2 format, if we have this value, it's going to be a 1. If we don't have the value, it's a 0. Because we only have 1s and 0s. Because it's base 2, there's only 2 digits. With base 10, you get 10 digits. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And they represent that many. So for a given binary value, let me just go down a page maybe. Here. If we wanted to store 42, right? Let's say 42 then. Those are a little bit long here. That's okay. So we have 1s, 2s, 4s, 8s, 16s, 32s, 64s, 128. There are no 128s in 42, so we have a 0. There are no 64s in 42, so we have a 0. There is a 32, right? We could take 32 away from 42. We'll say that one's on. So what's left over then, right? 42 minus 32 is 10. There are no 16s in 10. There's an 8 in 10. Minus 8 gives me 2 left. There's no 4s left. There's a 2 left. 2 minus 2 is 0. There are no 1s left. So in binary, I would say 42 is 0, 0, 1, 0, 1, 0, 1, 0. That's 42. Okay, don't worry too much about any of that math. I'm not going to make you do binary numbers. But it turns out the Windows calculator actually has this really cool mode called programmer mode. The programmer calculator, made for us. And if you go to binary, you can go to bit toggling here. And you can see, hey, I can individually turn on different bits. So 1, 0, 1, 0, 1, 0 is in decimal 42. Right? 4 10s, 2 1s. 42. 1, 0, 1, 0, 1, 0 in binary, which is pretty cool. So if we go back to an individual integer being 4 bytes here. Now, the other piece of this is integers can be positive or negative. So one of these bits then needs to stay to indicate positive or negative. So the first bit, or I actually forget which bit it is, we'll just say we're going to leave the first one alone here, and that will be 0 if it's positive, it'll be 1 if it's negative. Why not? So I have 31 other bits here then. So if I turn on all 31 other bits here, we're going to see the largest number we can store in binary form as a 4-byte integer. Let's go flip all these ones on, and it looks like 2,147,483,647 is the largest integer value that Java can store. So generally, that's a pretty big number, but I just read yesterday that Microsoft and their Xbox org just offered to buy out Activision Blizzard for $69 billion. So we would not be able to do that arithmetic using Java integers, unfortunately. Right? 69 billion is a bit more than 2. That's unfortunate. So I didn't actually know Call of Duty and their games were worth that much, but I don't know. I've never actually got into Call of Duty. I've played StarCraft. I was really big into StarCraft. I've played a little bit of World of Warcraft. Played some Overwatch. I'm trying to think what other games do they have. Apparently they own King and Candy Crush too, which is sure. Maybe that makes a lot of money. I don't really know much about that one. And Diablo. Yeah, Diablo's a pretty big franchise in Blizzard, so I've played all of those ones as well, which is really cool. And Microsoft, I think they've got a decent reputation in the industry for being pretty fair with their hiring practices and promotion practices and diversity. And Blizzard had a pretty dark time recently, and they got in the news for some pretty terrible practices. So hopefully this is good. We'll see them not fade into non-existence. So I don't know. Any of you play Blizzard games or Activision games? Alright, so that's our binary bit here. So doing arithmetic is going to be fine up to that 2 billion or so odd number, which is pretty cool. So if we have an int for a really big number, we could say that 2 billion number. Or it turns out, if you just say integer with a capital I dot, in Java there's already a built-in max value for you, integer.max value. We can print out the max value, the really big number. Now what happens though, if you're doing this sort of arithmetic, hey Rocker, what do you play? Anything in particular? If we take and we want to add something to a really big number here, let's say, hey, I want to print out the really big number plus 1. So this now is arithmetic, because a numeric value plus a numeric value will do arithmetic, like you'd expect it to do. When we say a string value here, a bunch of text, plus something, we're not really adding. It's just concatenating. It's taking the value, sticking it on the end here as a string format. So we're going to get some weird results here when we add 1 to the max number. It goes from the max number to, oops, it just flips around. Now it's the minimum number. So it's a little bit unfortunate here. So you've got to be careful that you don't go over max or under the min, really, because the math gets weird here. Excuse me, I have to sneeze. All right, I think I hit the mute button in time. Did that work out okay? Didn't blow your eardrums out or anything? Oh, whew, that was a good sneeze. Oh, and this class file we can get rid of here. We don't actually need that generated class file. Okay, so you have to be careful with these really big numbers. So adding to the max int value is bad. So these // these are individual comments, and when the Java compiler runs, anything that's in a comment is literally ignored and not included in the compiled code. So all that stuff that's in the class file does not include your comments. They're just gone, ignored, which is really cool. So these are notes you can leave. I tend to follow one of the general consensuses in the industry is that comments they're not particularly useful. In general, they mean that your code isn't really clear what it's doing. Oh, Bethesda, yeah, they got bought out by Microsoft too, didn't they? That was pretty cool. They've got some really good games. I had a really good run of Skyrim going. I was close to 100%ing it. Not quite there yet, and I kind of lost a little bit of interest, but I think I got maybe like 90% of it done, which was pretty cool. But that was such an iconic game. It was fun. So these comments here are just going to get ignored by the compiler. Actually, I'm going to put that up one here. So let me put it above the line. So generally, if you have to leave a note, your code probably could be clearer as to what it's doing. And not all the time. You know, there's definitely good times to leave comments, but that's kind of a rule of thumb. Like this variable here, really big number. If you need to leave a comment and say storing a really big number, your variable name is probably bad. It's like, don't call it A and then say storing a really big number in A. Just name your variable really big number. And you'll notice the way I've named this here, variables should always start with a lowercase letter, and then every next word gets an uppercase letter. So big and number are uppercase, and we call this camel casing. So that way, it's just kind of at a glance, you can see where the next words are. It makes it mostly readable. You'll get used to it. It's a little funky at first, but you can kind of look at a variable and read it without a lot of work. If it was all lowercase, it'd be a lot harder. And generally, variable names will start with a lowercase letter. Other things start with capital letters, like the name of a class here. So notice this is public class chapter 2 with a capital C. The name of the file is capital C chapter 2 Java. That's our convention. So anything that's a class here should have the starting uppercase letter. Packages are all lowercase, that sort of thing. So a lot of magic happens behind the scenes for us, but it just works out nice. So like my favorite number, lowercase letter, and then capital letters here. Kind of imagine a camel with the humps on its back, right? Those are the capital letters of the humps here. Those are integer values. So the problem with integer values are there are no decimal places. So if you want to store something with a decimal place, you got a couple options. My favorite and the most common, and what we're going to do for this class, is we're going to use something called a double. So a double is a number with a decimal. And we could store, I don't know, like 7.7. Okay? So doubles are able to store, I believe it's up to 15 digits of precision. So up to 15 decimal places you can store in a double, which is pretty cool. That's pretty accurate, right? Most of the things that we need to do work out pretty well. And actually, there was a really cool article put out by NASA. Was it how many digits of pi do we need? I think it was NASA. And no, that's not the link. Where is it here? It's like through their Jet Propulsion Lab or something. That's not the one. This one, yeah, the JPL, Jet Propulsion Lab. That's the one I wanted. Yeah. So, Interplanetary Navigation, they only use this many digits of pi, right, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So for 15 digits of pi, they can take Voyager 1, which is going, 25 billion miles away, and, oh no, okay, so for more than 78 billion miles, they can get within 1.5 inches here, using pi at the 15 decimal places. Right, so you don't need tons of decimal places, right, to be super accurate here. So this was kind of cool, I thought. 40 decimal places if you wanted to calculate the circumference of a circle with a radius of 46 billion light years with the accuracy equal to the diameter of a hydrogen atom. Wow, that's some cool stuff. Math is neat. So anyway, don't need tons of digits usually for that sort of thing. So a double should probably get us pretty close to what we need. Now, a double takes up 8 bytes of memory. Remember, an integer's 4, a double's 8. So in 8 bytes, we can store pretty large, accurate numbers. And I don't actually remember what the largest value is here. So let's Google that one too. So let's do Java max double and see what we get. Double max value. Excuse me. Let's see. Where does it say it? Where does it say it? Oh, okay. Somewhere around 1.7 times 10 to the 308. So 308 places. Wow. That's like a Google is 100 zeros, and we're at 300 zeros here. So probably going to work pretty well for us, I think. Right? That's a pretty big number. I don't even know what comes after that. Right? I can do billions and trillions and quadrillions and then centillions, and then I start losing count here after that. But so a double then can store lots of really big numbers with 8 bytes. And the reason why that works here, right? If you go back to our calculator here and think of that base 2, every time we add just one more bit, we've doubled the amount of stuff we can store. Right? So at 32 bits here, I can store 2.14 billion. If I go up just one more bit, now I've doubled that. I'm at 4.29 billion, right? Double, 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 all the way up to here. That's a whole lot of zeros there because I've doubled and doubled and doubled and doubled and doubled and doubled and doubled. It doesn't even show up as an actual decimal number here. The RuneScape number, yeah, 2.147 million. So yeah, that's the max integer value. So we don't even know what these ones are. These are just super large here. So I wouldn't worry about it here. We get some big numbers. Yeah, you can't go past the max int. So if you store something as an integer, you run into problems. So there's actually a funny story here. What is it here? So it was the NASDAQ. Max int. And that was for Warren Buffett, right? What's his company called? Warren Buffett's company. Berkshire Hathaway. So the way that stocks were tracked in the NASDAQ stock exchange is they would store a value using, I believe it was just 2 bytes, right? Was that it? No, 4. It was 4 bytes. Yep. So they were storing numbers with 4 decimal places, but as an integer, because they didn't want to deal with doubles because they were large. So they were using what's called an unsigned integer, which is it can't be negative. It's only a positive number. So they could get to double that 2 billion, right? If they didn't save the 1 bit to say this is positive or negative, if it was only ever positive, they could get to double that. And they stored it as number of 10,000th of pennies to get accurate stock prices. And it turns out Berkshire Hathaway, their stock, because Warren Buffett does not want to split his stock because of whatever reasons he has here, they were going to get over that large number. Larger than it could be here. So that was a kind of a problem here. And they had to go and upgrade their systems so that they could actually show the accurate price here. That was just a funny story. So max ints deal, they're problems for people. Anyway, so double, number with a decimal place. Right? We can deal with that. You might see there's another one you can use called a float. A float is a number with a decimal place, but it only takes up 4 bytes. So it's another way of storing numbers here. I don't like floats. Eric is not a fan of floats for one particular reason here. So if I say a float is 7.7, Java's going to yell at me here. And if I hover over it, it says Incompatible Types. Possible lossy conversion from double to float. So anytime you, in your code, have a number with a decimal place, Java assumes it's a double. And doubles could be more precise, right, have more decimal places than a float. So it says possible lossy conversion from double to float. Hey, by the way, you might lose some accuracy because you're losing some decimal places. Now, I'm not using 15 decimal places, but Java doesn't know. I mean, I wouldn't say they're better, Crow. They're larger, and they're the default. So for the things that we're doing, we don't care if it takes up an extra 4 bytes of memory. Topspin, oh yeah, you got a hex number, awesome. Quads, I'm sorry, I'm not sure what you mean by that. So if you want your number with a decimal place to be treated as a float in Java, you have to put the letter F to tell it, yes, this is a float number here. Oh, I don't know. That doesn't ring any bells for me, but I've never done Fortran. So this is why I don't like them, because you have to put an F. Why add an F? So I think it's annoying, so I never use them. Now, it is a good thing. So if you don't need that level of precision, it's better to use something smaller. For our purposes, we're still just learning here. I don't care. And 4 bytes of memory, we could care less. I mean, if you have thousands of these, you've saved 4,000. That's minuscule, right? So a single byte is 8 bits. A kilobyte is 1,000 bytes. A megabyte is 1,000,000 bytes. A gigabyte is 1,000,000,000 bytes. So when your computer has gigabytes of memory, you have billions of bytes of memory here. I don't care if you saved 4,000 bytes. It really doesn't matter. We're spoiled, right? Let's be honest. We can be lazy at this scale for the things we're doing in this class. Now, when you move on to bigger and better projects and more interesting things, when you're doing something at a million times scale, if you're storing millions of numbers, yes, saving 4 bytes times 1,000,000 is going to be meaningful, definitely. But for our purposes, we're just going to be lazy because we're never going to do anything at that scale in your very first programming class. Go for it. Do the doubles. You don't need to. You don't need to deal with floats. And then you don't have to remember to put an F places. I don't know who came up with that. So add the F for float here. No, again, I'm just not a fan of them. So I'll just be lazy. I'll use doubles. So I use integers and I use doubles. If you want really big integers and you don't want to deal with doubles and decimal places, you do have an option called a long here. So it's a really big integer value. Really big number here. I forget. Something like that. And I think with this you have to put an L in, which again is obnoxious. Which looks like a 1. Now the cool thing here is you can throw underscores in. And I definitely encourage that. So underscores get ignored. You can just use them as separators here. Should I put one in? No. That's an L. It's really hard to see. Again, they're obnoxious here. It's really hard to tell that that's an L and not a 1. And an L for long. I think I can do a capital L. Maybe that's better. Yeah. So capital L, probably better than the lowercase l. Uppercase or lowercase. Should be fine. So longs are twice as big as integers. And they're 8 bytes as well, but they don't deal with any decimal places. And longs are great. But again, we're not going to do with anything that large. So we're probably fine with our ints, with our floats, our doubles. So just ints and doubles are the easy ones to use. But you've got options, okay, for storing things. Now, other values you might see like char for character. This is how about my first initial? First initial. So a char is a single letter you put in apostrophes, not quotes. Apostrophe, not quotes. It holds a single letter. If you want more than one letter, you want something called a string. And this is a capital S string. Notice all these other ones here are lowercase, and they show up in this cool orange color here in dark mode. These are what's called primitive types. String is actually a class in Java. Don't worry too much about what that means, but that's okay. So we'll do my name, and then I can assign it the value of, now this gets quotes, and we'll put Eric Chernesky. Quotes for strings. So a string is really just a bunch of characters, a string of text. Right, a string of characters, where a character is a single character. Right, so hopefully that's helpful. String is a bunch of characters. A character is just one. It gets a little bit funky here, but that's a really common one. So anytime we're dealing with just text, we're going to use strings. So all of these things let me store this information. And what happens is you're declaring a variable here, and then we're assigning it a value or initializing it. We're telling Java, hey, please go store something in memory. I want to call it this. And then Java says, or when Java runs, it says, hey, operating system, I need 8 bytes of memory, please, so I can store a value. The operating system says, okay, here's a location in memory. And then Java says, okay, please write this information to that location in memory. And your operating system says, sure, I'll go do that thing. It's really cool. There's a lot of back and forth and magic that happens behind the scenes. So we can store all sorts of information. All right, so we've got all of that, and let's see. So we can use these then when I'm outputting things. I can use my variable name. So I can use my name, my name, plus. So again, plus with a string is going to do that concatenation. It's going to take something and just stick it on the end here. There's no actual arithmetic happening. So we'll say favorite number is, and then I want to concatenate on here my favorite number. My favorite number. There we go. So it's going to take this string of my name, smush it on with this, and smush on my favorite number here. So notice I'm adding the extra space here, so that when things get all smushed together and concatenated, it'll look a little prettier. Excuse me. Right, Arithmetic's favorite number is, oh, it's not 10, that's wrong. 10 is wrong. Let's put that back to 42. 42 is a much better number. Much better. There we go. Now we see my favorite number is 42. So the output here can use these variable names so that you can see what it is, and these things can be changed here. We haven't gained a whole lot if I'm really just using it one time, but if you're going to use my name multiple times here, right? So like my name plus is first initial is, and then initial. So you notice I'm not actually typing my variable names here. I'm doing like a couple letters here, and then I'm hitting tab to autocomplete. Weirdly, that's not the default. So go to Tools and Options, go to the Editor section here, go to the Code Completion tab, and pick Java from the language, and make sure you check boxes 2 and 3. For auto pop-up, I'm typing any Java identifier part and subword completion. Check those ones, and then you'll definitely get that type ahead stuff working for you. So once you have a variable name, you just start typing a couple letters of it, like my first, and then you can up and down to pick between the two, and then tab will finish typing it for you. It's super handy, right? That's why long variable names are great, because you don't even have to type them all. You just type a couple letters of it, and it says, oh, do you want this one? You say, yes, please, I want that one. And then it finishes typing for you, right? Be lazy, and I mean that, you know, in the nice sense. You want to be efficiently lazy, right? Don't do more work than you need to. Let the tool do all the work with the shortcuts. It's amazing. It'll make you more productive, which is great. And then, you know, you'll be less frustrated at this sort of thing. Another general rule of thumb, when we're doing code, you'll notice there's like this ever so slightly faint kind of line here. Sure, generally don't worry too much about it, but usually that's about where you'd have to scroll the screen left and right, depending on if you're widescreen or not. Because the code here is for people, right? It's generally considered bad form to make your code scroll to the side. You want to be able to see your code just by scrolling up and down. If I have to scroll right and left, you've made it harder for me to read your code, or harder for you to read the code, harder for someone else to read the code, and that's bad form. Okay? Java doesn't care where our code is. Right? The Java compiler, as long as we have the semicolons in the right spot, Java could care less. So all of these things could be bumped down if we wanted to. I could say, hey, my favorite number is, and then I just go to the next line. As long as I have the right syntax, Java is going to ignore the white space, right? So we could bump all these down if we wanted to, each on individual lines. If you try and split a string, NetBeans is pretty much smart enough. It will add the concatenation for you here. Now, this is pretty ridiculous, and this is less readable now. Like, what even is this? So this is not helpful at all. So we've made it worse looking by doing all those extra lines here. But if you're going too far off the side of the screen, just bring it down a line, right? Nothing wrong with that. Just the semicolons enough. So the tabs are all convention. So generally, anytime there's a curly brace, code should be tabbed in one level inside of it to show that it belongs to that curly brace. It gives you a visual cue to where the code belongs. And you don't have to manage any of that yourself. If you go to the source menu and hit Format, it will tab everything for you. Or you can grab like multiple lines and shift tab or tab them places. So if it's in a really funny state and some of these things are tabbed a bunch and some of these are not tabbed and you got a bunch of weird spaces places, just auto format. So Alt Shift F or go to Source and Format will format it for you. The only thing it doesn't do is the comments, again, because comments are terrible generally. So I go fix those myself. Yep, just the semicolons enough. So that indicates to Java that that line is done. So we could be obnoxious and put all these things on a single line here. This is legal Java code. It follows the Java syntax. There's a command, ends with a semicolon. You don't have to go down to the next line. You're just supposed to, because this is ugly. So I'm going to undo that. I think probably like 2 characters, maybe 3. So like if I just type my, I get it. If I just do M, it probably works, but it usually takes a little bit longer. So like if I don't have anything typed and I hit M, it takes it, like lags for a second. If I give it 2 letters or 3 letters, usually it's a little bit more specific. So I'll go a couple letters here and then tab it in. And you also get suggestions for things that are not useful sometimes. So like the more specific you can be, you won't get those ugly ones here. Right, so take advantage of those. They're fantastic. Okay. All right, so we got some variables. I think we're about due for a break here. We're about an hour in. And when we take a couple minutes, we'll come back. We'll wrap up the topic for today, and we'll talk about the lab we're going to work on and the project we have assigned. You know, we haven't really gotten far enough. Shoot. You know, I think I'm going to wait on the project, and we'll talk about the project next week. Is that going to work? Let me look and see over break, okay? So let's take 10. We'll put some music on. We'll chill for a little bit and come back, say in about 10 minutes, and we'll pick it up from there. Yeah, so if you're not getting the suggestions, go to Tools and Options. Go to the Code Completion, or the Editor section, Code Completion tab. Pick the Java language. Make sure you check boxes 2 and 3, SB Java. That'll make sure that pops up for you then, okay? All right, we'll take 10. We'll come back in a minute. And see you folks in a little bit. Go get some coffee. Hey folks, welcome on back. Alrighty here. So I don't want to take up too much more time with talking and lose the time to practice here. So let's take a look at our schedule here and see if we can adjust some of this, because I don't think we're going to get enough in here yet to get to the project. Maybe we will. Maybe we'll have enough. Let's see. Maybe I can remember my password too. That'd be nice. Oh yeah, definitely. The answer to life, the universe, and everything is definitely the favorite number. It's got to be. All right, we'll take a look at the syllabus here. If we push it off too far, I don't want to get... We'll see. Let's see. Let's do... Come on, down to page 8. There we go. Yeah, no, I think that'll work. I think we can wait just a little bit here, because this one... Oh, does that put Project 2 into the midterm week, though? That does. Okay, so let's talk about... Let's get enough to get Project 1 assigned, because we want to be able to get 2 done before the midterm hits. Yeah, I think we got to do that. Okay, so we'll do a couple more things. So we need to look at arithmetic, and then we need to look at some control, which is really cool. So some basic arithmetic, right? I can say, hey, I want to take my favorite number, and if I want to add to it, I'm going to say, hey, change the value. So this is the assignment operator. So assign a new value. So whatever happens on the right gets assigned to the value on the left. Now, I've already told Java it is an integer, so I don't need to tell Java it's an int again. If you try and tell it it's an int again, it's going to yell at you and say, variable my favorite number is already defined in method main. So we don't need to tell it it's an int again. It already knows. We just say, hey, let's assign it the new value. Let's do my favorite number plus 10. So it'll do this arithmetic on the right and assign it to the value on the left. So this does arithmetic on the right first, then assigns to the left. Right, so everything on the right happens first, and then it assigns to the left. So that's how that one works. So we can do that arithmetic. We can take my favorite number, and we could say, hey, let's take, I don't know, how about 32 times 10 divided by 2 plus, or how about minus something here? So that'll be 60 minus 128, 118, right? Sure, it'll do this arithmetic. Now, order of operations still applies. And I don't know about you, but I get upset when those silly things go around online. I guess I'm still old enough that I use Facebook, and I'm not cool like everyone else who uses Instagram or whatever now. But order of operations is a thing. And you have to do them in the right order. So let's do, yeah, this one should be fine. Let's add in a plus here, right? So 5 plus this, right? And then let's minus 23. So order of operations says parentheses, exponents, multiplication and division, addition and subtraction. Now, just because you say multiplication first doesn't mean you do it first. Multiplication and division have the same order of precedence, so you do them left to right. Now, we're not running into anything weird here, because that's fine, but if you were to say, hey, here's another number is equal to 10 divided by 2 times 5, right? You don't do 2 times 5 first just because you said multiplication first. You do the division, 10 divided by 2 first, then you multiply by 5, because you're doing left to right. Operations, left to right, for same level of precedence. I don't actually know how that one's spelled, so we'll assume that's probably close enough. Here. So that means 10 divided by 2 happens first, then times 5. So you're going to get 5 times 5 will be 25. You're not going to get 10 divided by 10 is 1. Right? If you want something to happen first, put it in parentheses. Remember, that's how that works. So we'll get 32 times 10, then divided by 2, and then we get 5 plus that number, minus 123. Right? That's how math works. Okay, not too big of a deal, but if you want to force something, use parentheses. It's really easy, right? We could say, hey, let's do some parentheses here. Never hurts to add parentheses. They're just redundant, and sure, that's fine. We don't really care. Okay, so we've got numbers. So we can do arithmetic. Now, it turns out doing something like, hey, adding 10 is so common we have shortcuts. We can say my favorite number plus equals 10 if you want to add 10 to something. So this is going to add 10 and then assign it back to the left. This is just a shortcut for my favorite number. That's this one here. Right, just a shorthand notation. And you can do any of these. These are called combined assignment operators. You can do plus equals, you can do minus equals, you can do times equals, you can do divided by equals. No big deal, right? It's just a shortcut. What you want to be careful of, though, not the same as saying my favorite number equals plus 10. This here is really bad because plus 10 is positive 10. And you're saying, hey, Java, take positive 10 and assign it to my favorite number, to positive 10. So that one's real bad to flip these around. So you got to be careful, right? So it's operator and then assignment. Combined assignment operator. It's funky, but right. This is the legal Java syntax. Positive 10 being assigned to your number. Probably not what you wanted, though. Okay, so you got to be a little bit careful there. And it's not really going to warn you a whole lot about it. Right? This warning here is saying the assigned value is never used because I never go print it out again. My favorite number. So sure, we could print it out and see what it is. It says, hey, we never used it, we changed it again. Sure, that's fine. We could print it lots of times, but that's okay. We're not too concerned. Okay? So that's all the arithmetic that we can do. Now, just doing straight arithmetic is not all that interesting or all that useful. My goodness, we are running short on time here. That's okay. So one of the things that we can do then is instead of having all of these numbers just always programmed into our program, and it's the exact same thing when we run it every time, we can ask the user to type stuff in for us. And getting user input is awesome. So this is getting user input. So to do that, we're going to use something that's in the Java library, the Java API. All this stuff is built into Java. We don't need to reinvent the wheel. It knows how to do a bunch of things for us. So we're going to use something called Scanner. So Scanner is a class in the Java library that knows how to get keyboard or input from the user. I like calling it keyboard. The book calls it SC. It doesn't matter what you call it here, just some meaningful name. And I don't think SC is very meaningful. So I'm going to say, hey, I want a scanner. I'm going to call it keyboard equals a new scanner. And we're going to say, hey, please use the system.in in parentheses. So new is a keyword. It means, hey, make a new one of these things in memory, please. Scanner is the class. And we're saying use the system.in. That's the standard input here. Notice we have system.out. That's our standard output we've been printing to. So system.in is the input. So you can type stuff at the console and get that input. Right? Now it's still going to light up in red and say, hey, it doesn't know what a scanner is. Cannot find symbol scanner. So if you click the light bulb, occasionally these hints or these tips, fixes are useful. All the bottom ones here are gross. Don't touch them. They're not going to do anything that you want here. Only that first option is good here. Add an import for java.util.scanner. So because there's so much in the Java library, Java doesn't automatically give it to you. You have to ask for it. And to ask for it, up at the top of your code, you have to say you want to import java.util.scanner. So it says, hey, go to the java.utility library. This is the utility library. Import this class called scanner. Please, I want to use scanner. So this line tells Java, okay, go out to the library, go get this thing. None of it's automatic, but you can either type this line in if you want or let NetBeans suggest it for you. That's a useful suggestion. Here now, I can use this keyboard object that we have, and it does a bunch of things. So I can say, hey, here's a string for name. I'm going to assign it the value of keyboard.nextLine. Keyboard.nextLine says, get the thing the user just typed and give it to me as a string. So give me all the text, give it to me as a string. So now any name that they type in, we're going to store in the variable called name. And then I can print out, hi there, and then append in their name or concatenate in their name. So when they type in a name, anything they type in here, I'm going to keep using here. Right, so when I run my program, we get all that other stuff at the top. And then, sorry, I forgot. I got to do one more thing. Before we ask them to input something, we should actually ask them. Right, so we could prompt them and say, enter your name. Right, so enter your name so that they know what they should be doing here. Then they can type something in. So it says, enter your name. Okay, so I'll put in Eric. And it says, hi there, Eric. Anything I typed in here is going to get stored in that name variable here in memory somewhere. I don't know what they type in, right? They could type in a bunch of gibberish, right? Enter your name, they type in a bunch of gibberish here. I get, hi there, here's a bunch of gibberish, right? It lets the program be dynamic based on whatever the user, or the person running it, wants to do. It's actually a little bit more useful here. So if we wanted to build like a quick little calculator, I could say, hey, please enter, let's talk to them by name. So I'll say name plus, please enter a number to add. And now when we deal with numbers, so this scanner class, it has ways of getting other inputs, like ints and doubles. I'm always going to prefer next line. It gets confusing otherwise, so I just recommend using next line. So if I want an integer value, we'll say this is the first number. I'm going to assign it the value of, I can't say keyboard.nextLine, because keyboard.nextLine is a string, and it's going to say incompatible types. String cannot be converted to int. You can't take a string from keyboard.nextLine and store it as an integer. So what we have to do then is we need to convert it. So to convert, we go back to the Java library. We say, hey Java, this integer class, it has a method called parseint. So if I say integer.parseint, and then inside of the parentheses, I give it whatever they typed in here, keyboard.nextLine. It will attempt to parse it as an integer. So parse is just, how do I read it as an integer? It might crash and it might not. It's okay, don't worry too much about it. And then I'm just going to copy paste this because I'm lazy here. And please enter, we'll say another number to add. And then I have an int for second number. Integer.parseint, given whatever they've typed in. Your numbers added together are, and then I'm going to append in here first number plus second number. Right? Because I want to take the first number, add the second number, throw them together. We can do some arithmetic, right? First number plus second number, basic arithmetic. Let's see if our calculator works here. So enter your name, Eric. Says, hi there, Eric. Eric, please enter a number to add. Let's do 10. Eric, enter another number to add, 20. Your numbers added together are 1020. That's not arithmetic. So you have to be careful here. Order of operations is still applying. So left to right says, hey, here's a string. You want to add a number to it? Well, that's not arithmetic. So let's take your number and just smush it on as text here. Now, this and this is a string here, text. Yeah, SPJava. So I'm going to post all this to GitHub after the fact. So typing along as I go is generally not going to work very well. That's why we typically will have that lab time after. We're rushing a little bit. This is kind of unfortunate, the timing here, but we'll see how it goes. So I say, here's a string plus a number, and it says, okay, here's more text. And then more text plus another number? Sure, we'll just put more text on. So if you want arithmetic to happen, we put in parentheses. Let's force that order of operation here. Then when I run it, we get, okay, enter your name, Eric. Let's do 10 and 20. Now we get the actual arithmetic result of 30. Because order of operation says do the parentheses first. Oh, number plus number? That's arithmetic. Number plus text? That's just concatenation. So it tries to be smart, but sometimes can be a little bit funky here. So that's our basic calculator, just adding some numbers together. And we have to do arithmetic, though, we have to deal with things as integers or doubles. So we can do another kind of calculator here, like a basic, let's calculate your pay, right? So to do that, we're going to use double.parseDouble instead. So if I want a double some value here, I'm going to say that's equal to double.parseDouble given keyboard.nextLine. Next line, and then we'll ask them here, and we'll say, please enter some value with the decimal place. Decimal place, that sort of thing, right? And I can run that. And enter a name, sure, 10 and 20. We get some arithmetic, enter number with the decimal place. I can do like 7.7, and it works. If I run it and I give it something that's not a number here, like enter a number to add and I put in 10 in text, it's going to crash on me here. And that's okay. We're fine with it crashing. This is the stack trace. So it says it crashed. You kind of read from the bottom up at line 62 of our program. Line 62 is right here. Well, it crashed because the number format exception for input string 10. It can't turn 10 into a number. That was the exception. That's why it crashed. So same idea here. So if I give it a number with a decimal place, So enter a name, and I put in 7.7, it's also going to crash because it can't read that as an integer in integer.parseint is the problem. So if you want doubles, great, let's do doubles. So tell you what, let's just do the lab today. We'll come back with the project later, and we'll figure out what's going on. If we need to adjust things just a little bit, I think that'll be okay, because we haven't covered enough to actually get anything that we need for project 1. So let's talk about the lab here. And we grab the link here for your GitHub repository. So let's do a new lab, do lab 1. So we're going to do the text submission here. All you have to do is give me that URL. This will be due next week before class starts, so 10 a.m. And just 10 points. Remember, the points only matter within the lab category. Oops, cancel that. We don't have to call this lab 2. Now it has a name we can edit. And it should pick a nice name. There we go. Nice name here for labs. So here's our lab 2 link. So grab the invite link, copy it for lab 2. You submit the feedback pull request URL. Write a program that asks the user for their name, then uses that in the prompts below. So just like we did, hey, what's your name? Right? And then we'll use that like name. Here's the prompts here. Yeah, definitely, yeah, the labs you're welcome to talk to the tutors about. They're not going to like solve it for you, but they'll get you pointed in the right direction for sure. Definitely. So ask the user how many hours they work. You know, it worked this week. Allow them to enter fractions. I don't know, partial hours. Right? That means you have to use a double. Ask the user how much they get paid per hour. Allow them to enter partial dollars. Right? So like $7.25 or whatever, you know, that sort of thing. So again, doubles here, and then calculate your gross pay and display gross pay and calculate an estimated net pay by taking, I don't know, let's just say 10% out for taxes. So display the gross pay, calculate the estimated net pay, take 10% out for taxes, display the estimated net pay. And sure, we'll just pick a number here. Not too big of a deal. We'll just do 10%. It's probably pretty different for different people, but it's okay. We'll just assume 10. Okay, so that's what we're going to work on for the lab. So doing these prompts, doing these conversions here, doing that arithmetic, and outputting some values here. So again, for doubles, it's double.parseDouble, right? Because integers are just whole numbers. So if you work a partial hour, you should get paid for that partial hour. If you make $10.25 an hour, you should make that extra 25 cents an hour. Don't use integers, right? Because it won't make sense. All right, so I'm going to commit the code here. So here's chapter 2 started. We'll finish this up on Monday, and then we'll talk about the first project as well. So we'll do that instead, okay? Because we just don't have enough time to finish it up and talk about the project, if that's all right with you. So we've got the rest of today, another 20 minutes or so to get working on this lab. It should probably be about enough time to get it done. We might need a little bit extra time. Don't worry too much about it. We've got until next week to get that one going here. I want to make sure we've got some class time reserved for that. And I know a couple people had issues getting everything installed and up and running. So I was going to try and meet with some folks today and make sure everything's up and running for you, okay? All right, don't forget you got the Chapter 1 quiz and Syllabus quiz due tonight as well. So make sure you get those ones in, and we'll go from there. Any other thoughts, questions, or concerns? So I've got that code out here. Remember, you can go view it here in content. You can go to the link to the GitHub repository. So you know, if you were following along with the Chapter 2 stuff, that's all you. All I need is the lab stuff from you for that lab assignment. So you can go check out the course GitHub repository here. We'll link you out to github.com/lab /Eric/CIS 1500 winter 2022-MW for Monday, Wednesday. And you can see all the stuff from chapter 2, right? You can just browse it right in here. So this is all for your reference out here available, okay? If you got any thoughts, questions, or concerns, let me know. Yeah, for the chapter 1 quiz, if you needed a little bit of extra time on it, I know some people were still waiting on books and stuff. D2L will say it's late, but don't worry about it. I'll ignore it. Yeah, that's no problem, because we still got to figure out getting books and all that. So I know we're just in week 2 here, so no big deal on that one. Yep. Cool. All right, folks, if you got questions, find me on Discord or shoot me an email, text me, call me. We can go from there, okay? You folks have a good one. Yeah, the new project. So you click the link for the GitHub repository, just like we did for Lab 0, and you want to accept the assignment. So let me open this one up for editing. You say, yeah, I want to accept the assignment. You count to about 5, you hit refresh, and then you get the link for your repository. You'll click that green code button, say Open with GitHub Desktop, and will allow you to clone the repository. It's going to accept. We'll count to 5, refresh. I've got a link to the repository here. Click that link. Click the big green code button, say Open with GitHub Desktop, and it's going to say, hey, do you want to clone this repository? We're going to say, yes, let's clone it. Great, it goes to your Documents GitHub. Once you've got it cloned, now in NetBeans we can start the new project. Go to File, New Project, and we're going to pick that folder. So again, Java with Ant, Java application. Now, in the location here, don't leave it in Lab 1. Go change it here, and let's go find that repository. It's just a folder. So we're going to hit Browse, look in your GitHub folder for, here's the Lab 2 folder here. Put it in the Lab 2 folder, say OK, I want to open, and give it a name like Lab 2. Lab 2, sure. So it's going to put Lab 2 inside the Lab 2 repository. We'll say Finish, and if we got it in the right spot, the GitHub client's going to say, hey, great, there's a bunch of new stuff here. You're up and running. Right? The Lab 2 project is here. We're good to go. It's going to start tracking all those changes. Yep, and now we should see all the NetBeans project files. There's a Lab 2 Java file. If it sees the stuff, we know we got it in the right folder, and we're good to keep going. Okay? Awesome. Let me dump this. I gotta change that template, but that's fine. And then commit and push, right? Commit and push. You'll be able to see it on github.com. So this is Lab 2 started. Okay? Commit and push. Yep, we're going to do that for every lab, for every project. So it's just its own folder. Just to help keep things a little bit nicely organized for us. All right, folks, don't forget your coffee. Have a good one. I'll be around if you got questions.